and welcome. You should be on page 30 of your Algebra 1 Quarter 2 notebook. We are going to continue talking about solving systems of equations in word problems. So remember, we're going to read our word problems. We need to write two equations, find the solution, and then we need to answer the question. So let's look at number 3. One day, Phil purchased 5 loaves of bread and 3 muffins for a total of $8. A few days later, he purchased 2 loaves of bread and 6 muffins from the same store at a total of $5.60. What is the difference in the cost of a loaf of bread and a single muffin? So what I'm looking for is the difference in cost equals question mark. So what do I have? I know that I have muffins. So we'll say B equals, because I'm going to find the difference in cost, I suspect B is going to be the cost of bread. And I know it's a loaf of bread, but it's too much to write loaf. So M will then be the cost of a muffin. So I'm looking for the difference in those two variables. So what information do I know? I know that he buys 5 loaves of bread and 3 muffins for $8. So let's just say bread was $1. I would do 5 times $1, right? Or 5 times the cost of the bread. So my first equation will be 5b plus 3 muffins, 3 times the cost of a muffin, and that should come to $8. A few days later, Phil goes and gets 2 loaves of bread, so 2 times the cost of that bread, plus 6 muffins, so 6 times the muffin, and he ends up paying $5.60. So I do have 2 equations. I do want to mention that if I were to solve this algebraically, I would probably multiply this first equation by -2 to get a -6m, and then I would go for elimination. But I don't have to do that. I can use Desmos, and I'm going to have B be my x and m be my y because I cannot use variables other than x and y in Desmos. So let's take a look. I have 5x plus 3y, and that equals 8. All right, there's that first equation. Then I have 2x plus 6y, and that will equal $5.60, and I'll just write 5.6. So I can see that these two equations intersect at my solution of 1.3, 0.5. So here's my x, and here's my y. Now remember, my x and y represent cost of bread, so it's money. So x equals $1.30. You got to add that 0 so it looks like money. $1.30 is the price of bread. And y is 0.5. I'm going to add the 0 because it looks like it's 50 cents. And that's the price of the muffin. So now I've got my answer or the solution to this system, but I need an answer, which is the difference. So I'm going to take $1.30 and subtract 50 cents. And the difference is 80 cents difference in cost. And that is the answer to this question. Alrighty, let's take a look at number 4. That's another coin problem. If you remember from the first video, we solved a similar one, except in this case, I want to know how many of each coin does he have. Well, he has quarters and nickels, so I want to know how many quarters and how many nickels. So it looks like Q is going to be the number of quarters, and N will be the number of nickels. What equation can I use first? I know that he has 16 total coins. So it looks like if I take his quarters and I add together the nickels, Stuart will have 16 coins. I also know that if you take the value of all of them, they'll equal $1.40. So if I take how many coins he has and multiply it by the value of a quarter, let's say he has 2 quarters, it would be 2 times 0.25. So whatever number of quarters he has, he's going to multiply it by 0.25, the value of a quarter. And however many nickels he has, a little too small, he will multiply it by 5 cents, or the value of a nickel. So now I've got my 2 equations. I'm going to just get rid of these. And I will put, I need my x and y labeling here. X, y, just in case I forget. I've got 0.25x plus 0.05y equals $1.40. And then I have x plus y equaling 16. Oh, by the way, if I were to solve this algebraically, I think I would rewrite this equation to isolate one of the variables and use substitution. Again, I didn't have to do that because I've got Desmos. And here we go. Here's my intersection. I've got an intersection right here at 313. So it looks like x, which is the number of quarters, is 3. So there are 3 quarters. And y is the number of nickels. And so there are 13 nickels. So the answer is 3, quarts, not quarts, quarters. 3 quarters and 13 nickels. Now, I can make sure that these work into my equations. Does 3 plus 13 equal 16? That I can do in my head. But does 0.25 times 3 plus 0.05 times 13 equal $1.40? Oops. I just want to move this here. It does, 1.4. So it does work. All right, we're going to do this final problem now, and this one is going to require us to do a little graphing on our own, but we do need to start with writing 2 equations. Zito needs a babysitter this weekend. Her regular babysitter has a long way to drive to make it to Mrs. Zito's house, so she charges a travel fee of $20 plus $5 per hour. Her next door neighbor charges $10 per hour. Hopefully you're recognizing this is kind of like a one-time number with variable situation. And what I really want to know is how much is she paying? So y is going to equal the total cost. And it looks like per hour. So x is going to be the number of hours. So I have 2 situations. I have the regular babysitter, and I'll write that in pink. I'll call that RB, will charge $5 per hour, there's my number with the variable, plus $20 fee. The neighbor, next door neighbor, is going to charge $10 per hour, or 10x, and no additional fee. So I can graph both these equations. Now it looks like I got some labeling to do. I have 0, 1, 2. This is going to be x, the number of hours. And this will be the total cost. Looks like I'm going to count by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's take a look at graphing this first equation. We got y equals mx plus b. I have a y-intercept, or b, of 20. So my first value will be at 0.20. Then it goes up by 5 over 1. So she charges an extra $5 an hour for $1. And then 5, 5, 5, 5, 5. So this was my regular babysitter. I probably should have done this in pink, but I'll connect the dots in pink. And that's how much your regular babysitter is going to charge. Your next door neighbor has a y-intercept of 0. So your next door neighbor will start here. and they're going to charge $10 an hour. So they're going to go up 10 for 1 hour, to 20 for 2 hours, to 30 for 3 hours. And here's the intersection right here at 40 for 4 hours, 50 for 5 hours, and that's about as high as I can go. So now I'm going to draw that line. So there's a graph of what these are going to charge, and the question is what information can you infer from this graph? Well, the first thing you can infer is that your RB, or regular babysitter, and neighbor charge the same at 4 hours, right? At 4 hours, they are both charging $40. However, if you are babysitting for less than 4 hours, it looks like your neighbor is less expensive. Oh, I forgot the X there. Expensive. On the other hand, if you're charging more, so if you're up here at 5 hours, your regular babysitter is here at 45, whereas your neighbor is at 50, so more than 4 hours. Your regular babysitter is less expensive. So these systems are often really interesting and useful for finding out information about prices and costs and what the best choice might be. That's it for this video. Thanks so much, and bye.